I'm going to go over some of the exercises on page 141 in the Abu Badr text. Okay, this section is about standardization. This is a z-score. So here is the data set. He's got 18 students, and this is each one of these is how many hours a week they exercised. And I'm thinking, dang, that's a lot of exercise. They must not have jobs. Well, anyway, he wants us to find the z-score by hand. So this top formula and the bottom formula, they're the same formula. It depends on what book you get. So x by itself is any individual piece of data. Got it? X by itself, it's called the random variable, is anybody in a data set. And that x sub I means the same thing. That little I means individual piece of data from a data set. Got it? And then the mean is the mean. And this mu is for the population mean, which this could be a population, right? I mean, it's no big deal. So the standard deviation, again, is going to be the standard deviation from the data set. Now, this is a standardized z-score, and it is the father of this one. This was from a standard error. So if you're taking data from what you know for a fact is a sample, you need to divide that standard deviation by the square root of n. That turns this into the standard error. This all comes from the central limit theory. All right, let's get back to work here. Since he expects you to do this with pencil and paper, dinosaur times, I'm gonna try to show you his way first, and then we're gonna show you a much better way. Okay, so how do you find the mean? You add them all up. So I'm gonna pick that cell right there. I'm gonna go up to auto sum, which you can't see it. Let me bring it down here so you can see it here. Auto sum, that's this guy. Boom. And it asks you, what do you want to auto sum from? Usually it gets the right ones, but not always. Always double check to make sure it's highlighting the right ones. And that's the sum. And then how do you find the average? You divide the sum by the number there were. So there were 18. So I'm going to take that number, and I'm going to divide it by 18. I'm going to go to the function bar, type in equals, and then I'm going to tell the software to take that cell, divide it by 18. So there's the mean, 35. Got that? So now I'm going to do a shortcut. I'm just going to pick that cell. I'm going to go to the function bar, and I'm going to make sure I'm in statistical, and I'm going to go to average. Average is mean. Same. And it asks you, what do you want the average of? And then you highlight the numbers. I never trust these for some reason. I just highlight them. Boom. And what do you know? I got the same number. Okay, so the mean is 35. And then for the standard deviation, we're going to do the same thing. But I'm not going to do that one by hand. That one takes forever, literally. I mean, it is a huge process. So we're just going to cheat, and we're going to go here. We're going to go to the function bar, and make sure you're in statistical. So standard deviation. Wonder what letter that starts with. St. Now, there's always a couple of standard deviations and means and everything. So the P means population. The S means sample. Without going into a lot of detail, they're really, really, really close to each other at this point with such a small sample size. So we're just going to pick St. David. That P stands for population. Click OK. And this is saying, where do you want the numbers? And it is B4 through B21. I noticed that right now. So I'm just going to click OK here off screen. Bam. So there's our standard deviation. And you know what? I don't need it out to 15 place values. So let me get this back on scale for you. Sorry about all the bouncing around here. But this is your how many place values you want. And again, I don't need 10 of them. I just need a couple of them here. Let's just go out to 2 place values. All right, so there's my mean and there's my standard deviation. So now I'm going to type in, this is going to be my mean column. This is going to be my standard deviation column. And this last one will be the actual z-score column. Z-score. And the z is a little z. Don't ask me why. So the mean is 35, I know that. Standard deviation was 4.51. And again, the reason I'm doing this is because he wants you to do it by hand. A lot of the teachers want you to do it by hand. That's not a big deal. But to be honest, with today's technology, I don't think it's very helpful. All right, so we're going to paste them all the way into everybody. So now we're going to tell the software to do some calculating. So to calculate the z-score, we're going to click that cell, go back up to the function bar. When we hit the equals, that tells the software that something's coming, a function. So what I want it to do is, I want it to take, and I'm going to put my parentheses in there because I know when I'm going to need them. So I'm going to take that first real value, that's our random variable, our first real score, bam. I'm going to subtract it from the mean. I'm going to put my parentheses up there, right? Order of operations. And then I'm going to divide it by the standard deviation. Bam. That is that guy's z-score. So again, I'm going to just put it down to 2 place values. And I'm going to center it. Boom. And I'm going to put a box around it. Boom. So here comes the magic. I just click and drag this. And those are all your z-scores, right? So remember, the z-score of a normal frequency, right? If the data is normal, the mean of a standardized normal distribution will be 0. So any positive z-score is greater than the mean. Any negative z-score is less than the mean. So that's how you get your z-scores part 1. So here's how you get your z-scores part 2. Let me make some working room here. I'll delete these formulas. Delete those formulas. Now, since these scores here, the z-scores, you'll see that they were calculated by formulas. If you make any changes to any of these other boxes, these numbers will change. I don't want them to change. I want them to stay the same. So I'm going to highlight them. I'm going to copy them. Copy off screen. And then click in the first one, paste. I'm going to just paste the numbers, right? Just the values. So when I start changing something, that number will not change. Got it? That's what we want to do. So 4.51. So these are the legitimate z-scores that we hand calculated, kind of. And let's make them yellow or something. Boom. All right. Now let me show you the magic of Excel. I'm just going to pick this one. I'm going to go to the function bar, and it will give you the z-scores. So here it is right here. We're just going to go to standardize. It's going to standardize each individual piece of data, right? And so it wants, the first one is, what is the random variable? And that is the first guy's number 40. And the average, we already figured it out, is what, 35. And the standard deviation was 4.51. And click OK. Boom. And then we click bottom right till we get that black cross. We click and drag. And what it's doing is it's dragging the formula. So it knows to change cells. Isn't that amazing? So now, again, we don't want 6 place values. We just want a couple. And they should be the same. So these are z-scores from Excel. Next, he wants the mean, the median, the mode, and the standard deviation from the z-scores. All right, okay, so again, we're going to cheat. We're going to go to the function bar. We're going to hit equals. And then, let me give you a shortcut. If you just start typing the word average, average, all the functions with that in there pop up. It's usually the first one, average. Click on the little f of x, not the word, but the f of x. That's the function of average. And it says, okay, it's weighting the average of what? You're going to highlight your data set. And this time it's just the z-scores. And you don't have to put a parentheses in there, usually, and you just hit enter. So the mean. the mean of a normal distribution that has been standardized, the z-score will be 0, right? These are all z-scores now. I'm going to show you some z-score stuff when it's connected to the p-values, or what he calls percentile values. But let me find the median first. So again, we're going to cheat. We're just going to type in equal and start spelling median. There it is. Median of what? Median of these guys. Show you another shortcut. If I copy that cell, Control C, paste it in there, it's still the median. You see that? But now I'm just going to go up here, put my little typer up there, and type in mode. Mode. And you'll notice the C5 through C22 is still the same. Boom. So there's the mode and the median. Oh, look at that. They're the same number, which they're very, very close to the mean, which is 0. That's another good indication that the data set is normal. The mean equals the median equals the mode, or is relatively close. Okay, same thing. I'm going to go up here and I'll just type in equals Saint Dev with a P. And we highlight the data. Enter. Boom. So there's the standard deviation. So now I'm gonna teach you what these z-scores mean using the normal frequency graph. In other words, the bell curve. So give me a second to get reset up. Plus, I don't like that many decimals. There are just 2. Okay. So remember these: the mean and the median and the mode. We don't care about these two really that much, but we do care about the standard deviation. Okay. The next part is important. It's going to connect these z-scores with what he calls percentiles, what everybody else calls p-values or sig values. So let me get a fresh sheet here, and we're just going to go by hand. And again, I apologize about the drawing here. Hold on a second. How come I'm not getting my... All right, you've seen these before. So we're going to make a graph here. And we're going to put, this is going to be a z-score graph, right? So z, 0. These are all z-scores on the x-axis, right? And we get a 1, and we get a 2, and we get a 3. And again, they go out to infinity, but we're only interested in the first 3. And then going this way, we get a -1, -2, -3. Same thing. Goes out to negative infinity. So these are the actual z-scores. This is your y-axis. This is also your frequency, how many. But to be honest, we don't need this anymore. We don't really need the frequency. We got to know this, that the normal data set kind of looks like that, right? And these lines are what we call asymptotic. They approach each other. They never actually touch. Okay, that's all you need to know. So but these are z-scores, and the area under this curve is 100%. Remember that. The area under the curve is 100%. So if you get somebody with a z-score of 0, boom, that literally means what you do is you divide it in half, which means that you got 50% on one side and 50% on the other side, right? So the question might come out, what's the probability that if you pick somebody's z-score at random, what's the probability that your z-score would be less than 0? The answer would be 50%. Or 0.50. We're going to switch over to decimals here. But now, what if your z-score was here? Right? What if you had a z-score 2? What's the probability that your z-score was less than -2? That's a good question. You could kind of eyeball it, but that would not be a good eyeball, whatever that is. Now, we have a table. We're going to look that up here in a second. But these are what he calls percentiles. The area under the curve he calls percentiles. The rest of us call it probability values. Probability. Or just plain old p-values, okay? Or what SPSS calls sig values. And that sig values is a better way to think about it, because the way I want you to think about it is whatever this percentage is the percent or the probability that the null is true. I'll say that again. The probability values, I want you guys to think about it as the probability values that the null is true. So in other words, if I told you I had a car that I'd like to sell you, and I'm saying it runs in perfect shape. So if you get a probability value of like 95% that the car does run in shape, you would probably buy the car. But if you had a probability value of, like 2%, the car runs well and it's only 2% true, you probably would not buy that car, right? So these p-values tell us to either to accept the null or reject the null. But we don't say accept the null anymore. We say fail to reject the null or reject the null based on these probability values. So remember, a small probability value, how small? Less than 0.05, allows us to reject the null. So now we're going to answer the rest of his questions. So his first question is, if somebody had 32 hours of exercise, what would his percentile be? So you'd have to figure out his z-score, and I think it was... Here, let's just look at the data. Somebody had 32. There's a 32. His z-score was negative 0.67. So his score would be roughly here, right? Negative 0.67. That's a z-score, right? A z-score that goes to a z-score, that's what that means, goes to a z-score of negative 0.67. So that somebody's going to have a z-score of 0.67. Let me read the problem again. It says, approximately what percentile will a student with 32 hours of exercise fall? Okay, so he just wants the exact p-value for this. So in other words, we're going to look up the p-value of a z-score that equals negative 0.67. Excel does this, and I'll try to show you in a second. But I'm going to introduce you to the graphs. So hold on. So here's a z-table I made a long time ago. I had it stuffed underneath my triceratops. Nobody uses these anymore, but he wants you to start using the z-table. These are the z-scores, that first column. These are your z-scores. They're all positive, you'll notice. And this is what it represents. So the area under the curve, that's the blue shaded area here. The area under the curve for these z-scores are the numbers here, are the big numbers here, the 4-digit numbers here. So the numbers going across the top, the first row, is basically you add them to this one. So like this 5438, that is actually the area under the curve for 0.11. See that? 0.11. This one here, 5557, would be 0.104. That's how that works, okay? So we have a negative 0.67 on a z-score. Most z-tables, not the one in the back of this book, that is a hard one to understand, but this one is a basic one, so we go to the negative z-scores, and we want negative 0.67. So there's negative 0.6, and then we go all the way out to the 7. There it is right there. See that? So 0.2514 is the percentile for negative 0.67. Write that down. So the area under this curve would be 25.14. So in other words, if you pick somebody at random from that group of 18, you got about a 25% that they would be less than 32 hours. But then on the other side, it would be almost 75%. Remember, this whole area is 100. So I'm subtracting that from 1 in my head. Would that be 8? 6? Is that right? 1. Yeah, that's right. So the probability that it's greater than, would be this. That it would be less than, that would be this. That's how it works, you guys. That's how these work. Okay, so that is the z-table in a nutshell. Let's see what else he wants. Hold on. All right, his next question basically is he wants you to change this 32 to 36. So what's the percentile range of somebody that gets a 36? Let's go back. We got to change that into a z-score. And I think there was a 36 guy. There's a 36. So his z-score is 0.22. So he's a little bit over the mean. So 0.22 is a little bit over here. That's the 36 guy. But again, we're going to look up in our table, Mabel. Let's see, where is it? So we're going to look for the area for 2.2 z-score. There's 0.2122. 0.5871. Got that? So 0.5871, pretend the blue area is 0.5871. What we're going to do now is we're going to subtract out the 2.514. That was the people that were 32 and less than. So when we subtract out 0.2514 from, I already forgot what the number was, 22, boom, 5817. I'm going to pull up Mr. Calculator here. So the z-score for 36 was 2.2, and that was 0.5871. And we're going to subtract out the original 2514 minus 0.2514. That number was the 32 or less. So the difference of the two should give us the percentage of how many people were between 32 and 36 hours. So that's it right there. 33.57% of them exercise between 32 and 36 hours. All these numbers here, they're to the left of that. They're less than whatever this is, right? So the higher the z-scores, the higher the area, right? So if you had a z-score way out to the right, like a 3, that's practically the entire graph. You see that? That's what's going on there. So remember that. So all of these problems are either less than or greater than. So this will be the answer sometimes. The other times you have to subtract these from 1. If it's a greater than, you subtract these from 1. That's how these guys work. All right, the last problem that we can do is he wants us to calculate the Pearson skew coefficient, which, again, nobody uses anymore. But let's look that up here. So in the book, it's not quite right. I mean, I looked it up, and because I never heard of it before, but I looked it up. So Pearson's got 2 of them. One he uses the mode, the other one he uses the median. Okay, so the mode of our data set was 34, as was the median. So 34, let's go back to this bad boy. So the skew using the mode would be the mean, I think that's supposed to be the mean, x bar. Yeah. The mean minus the mode divided by the standard deviation. So our mean was 35 minus the mode 34. That's 1 on top. Standard deviation was 4.5. So the number comes out to be about 0.25 using the mode. Using the median, it's 3 times. Now, that should have said median, not mode. There's another mistake. Man, mistakes all over the place. So using the median, the second one, so the mean, which was 35, minus the median, which was 34, is 1 times 3. So it's 3 divided by 4.51, so it's about 0.75. So one says it's 0.25, one says it's 0.75, but since I don't have a reference for what those mean at all, I'm going to assume that the data is a little bit skewed, probably to the right. So, but again, we don't use those anymore. All right, hope that helps. MGZ, out.